started. Okay, so in terms of finding information in the code to make downloading more easier. Okay, you're okay there? You're set up?
Yes, yes.
Almost set up. Okay, so as soon as you're okay, we'll wait until at least one more person comes online before we okay. So I'm using this website, www.sdba.info, to allow us to, okay, so you try to remember that. We'll try to, I'll send that to you guys by chat. Okay. Hopefully, yeah, you can go there. That would be great if you can go to there first. You got your computer working again, Ansari?
My system is working, but the monitor, it means I am not able to see anything. My monitor is not working. Actually, there is some problem in my VGA.
Oh, okay, all right, okay.
Okay. From last 2 hour, I am trying to solve it, but still unable to solve it.
Okay, all right, okay, that's kind of a major problem, I think, yeah. Okay. All right, okay, Diane, you're ready to get online, sign on? Okay. Your laptop is having trouble too, okay, great. Yeah. Okay, no. They seem to have changed something with Google Meeting because it's, or else I cannot find my Surface camera. What's the problem? Oh, okay. All right, okay, now our camera is sort of functioning. Great, okay. Okay, now you can see me. Okay, great. Okay, we've got everything sort of functioning now. And we'll, okay, so okay. So let me know when your computer is functioning and completely answer, and then we can discuss how to continue on some of the programming if you have any time. Be helpful to continue that. Okay. Still. Okay. We're patient. Okay. I'll just okay. Okay, I've sent the link, so anyway, so this will give us to this page. And most of the stuff we'll be studying is all going to be based on this from this section. You can basically access everything from this page that we'll be working on. But so this is basically this is basically our textbook, and I just added a section on basic concepts. So the rest of it is basically stuff from another course I teach, but I added these 3 P, 1, 2, 3 basic stuff. Okay, so so that we can basically add, this is what we'll be doing at the very beginning on the basic concepts. Okay, you're on. Right? That should be you, right? Or not you? That's not you? No. Okay, hello.
Hello, Professor.
Good day. Welcome. Okay, we're still waiting, having one more student having some trouble getting logged on, so that's why. So I sent you a link, so if you can go to this web page, we'll start. I'll try to walk through it, what we're going to be trying to do using this website. So this is sort of Ali said it would be easier for me if we could upload most of this material so you can access it more easily. So that's what we're trying to do, so that we can make it more straightforward. Okay, good. You're on. All right, great. Okay, good. Okay, so it looks like everybody's on now. Okay. Have you been able to get to the web page yet? Okay, so I sent a link in the chat. You guys all got that link, I think, right? Yeah. Okay. You're okay? Okay, just a sec. I'll get logged, okay? You're in the meeting, right? Okay, that's good. So go to open then go to okay. We don't see us. You can't see me. Can you? Oh yes, you can. Okay, good. Okay, so yes, you want to go to that website. It's in Chrome. In Chrome. Yeah. Okay, good. Okay, great. Okay. Okay, good. All right. Okay, so we seem to be all okay. All right. So what I've tried to do here is to post everything that we're doing here. So basically, here's the section on the installing stuff that we did earlier. So this is the where we can get the Flash player to view the animation files that we have. So you'll need this file to be able to view the SWF files. This is class 1, which we did installing MeanGW and Notepad. This is class 2, where we talked about compiling, linking, running, and debugging. And that would be the YouTube where we recorded on YouTube. So it's under there. The second one is this guy P3 is our base, how we're going through this course, and basically it's everything, all the code, all the view graphs that we'll be trying to use during this to try to teach their different concepts. Okay, so this is our problem sets. I give you, okay, so since you guys are, so these are worksheets for the physics problem to help sort of written down in PDF format what we're trying to do, the optics, ray tracing, and the root finding for numerical analysis. So the idea of the physics one is to help us learn how we do data processing. The optics one is how we do simulation. And the root finding is to try to help us understand how to do numerical analysis. Okay, then in our first week, we had this section on, okay, the first was the introduction, install, so these are links to everything here. If you want to read this guy, you have to basically right-click, download it, save it, and then use the previous program to view it. These are our view graphs on compiling, linking. Again, this is the same file. We're going from slides 33 to the end. We then introduced the different applications. Those are the files that basically do that. We then talked about how we defined algorithms with UML. This is the file that talks a little bit about the UML. So you can look at it if you don't want to listen to it. And then we did the exercise of creating UML to represent solutions for each of these problems. And there's basically how we step through it. Then we started, how are we going to implement the algorithms with functions? So we talk a little bit about functions and pseudocode. And we tried to write commented code based on this UML. And in that case, you want to decide where you're writing your own function or using library or other people's functions. So basically, we have the UML here. For example, for this, the first code that we want to do, there's a picture of the UML of what we wanted to do for the first piece of code, which is this little piece of code we wanted to use for the first version of our code. And for the first version of our optics code was just this simple one. The multiplications, and then printing I and M, how much it gets multiplied by, how the magnification is. So we initially start with the object having a magnification of 1. And finally, we have this other one for our root finding one. Oh, sorry, clicked on the wrong one. The root finding UML. We would input, if n and p is 2, we input xs as p, we calculate, we do the calculation, we print xy is basically the UML code. All right, so we moved right down here. We talked about the functions. We moved through the variable code. We implemented with variables first. We saw how for the optics problem we needed a coordinate system, and we had to also make some corrections to make sure that it worked okay because of the problem with the being on the left side and the right side of the mirror. Okay, now we've moved all the way through here. We've completed the various pointers, and I think I'd like to first of all start by quickly reviewing these pointers, and then we'll go right on to the looping, etc. So the first one we want to convert will be this pointer file. So I think we'll work first of all with this guy, converting the pointers to the looping programs. So I would like, the code, you can just click here and get the code. So then you could just copy that. So you know that's the code we're going to convert. Okay. And then this is going to be, this is a data file. So this just tells you all the data here. So I just put all the data here. So you can basically think of it this way as looping through the code and shorten it. This is basically the data file of what we'll be processing here. So we don't have to keep type. So we have it here on your own computer. You can just look at it easily, the numbers you want to type in. Okay, so ideally we want to do this into repetition, which will allow us to do file entry to give us less typing into it. The conditional we used here to fix the lens equation. And we did conditional and repetition to auto converge into our pointers. Okay, so did we complete each of these codes last week? Which codes of these did we complete last week? Ansari, do you remember which ones of these did we complete last week? Pointers, okay. Did we? Okay, so
we also did a flow.
Do we do the looping ones yet?
Yes, we were doing looping ones.
We did do the loop?
Yes. Pointers were finished at more, it means before last week.
Okay. Did we do the guy for looping for the conditional and repetition to auto converge to the root yet?
Sorry?
Did we do this guy to try to make the pointers come into the loop? I think we did this guy. Okay. I thought we were still trying to get, okay, just a sec. I try to write down exactly what do I have with that? Pardon, I can't hear you. Sorry, the connection is not good.
You sent one code to convert it.
We did. Okay. I know
Hello?
we didn't do this. Yeah. Okay. All right. Let's quickly look at some. Okay. I'll look through all the looping functions first. Okay. And we'll try to show how they work, and then we'll look at how the program actually does work. Okay. So let's look at this the floating point solution for the floating point solution using pointers. Okay, and then we'll start to look at how we flowed that one through. Okay, I think that should be okay. File, save link as, save, show in folder. Okay, we'll go through this guy. Okay, so this is basically how we'll be working, trying to download everything. Okay, and so this is our following objects guide. Okay, we wanted to create repetition into this code, right? So basically right now we have these guys are coming through here. We're using pointers to allow us to get the information. This is our original code, and we wanted to try to create a looping function. So we wanted to loop through it, and so we did do the loop last week on this guy? No. Guy here said we did not do this yet. You used the while loop, right? We didn't use a while loop on this yet, did we?
I don't know whether we have it means I don't remember whether we have used our while loop or not, but we used for and while for some other function maybe.
For other fun, okay. I think we did. Pardon?
We just introduced while loops and other loops, but
okay. All right. So okay. So this code we're going to try to let you try to download this guy MG4. This is the code right here. Okay, the MG4, you can click here and download, just copy the code into your into Notepad, Control C, and then we'll get Notepad. So Notepad++ running, and let's close all this stuff. Okay, so there, so you're just going to download and then put this right into your thing. So this basically provides a pointer version of the code. And what you want to try to do is now to convert this so that we now have a loop. So right now, what are we going to have to do? So right now in the current version, okay, I have the loop. I have this. I can also download the let's file save as. Let's put it into SDBA. Save, and I also want to download the other guy from here. Where are we? Okay, so I've got that guy download, and I also want to download. Oops, I would also like to download this guy, mgdt.csv. I can then Control C, move it back to Notepad, and I'll probably just file new, file save as. I guess, yeah, I'm just and put it same directory, SDBA. Where is it? CCC, SDBA, and I'm just going to say yeah, exdt.text.csv. Probably .csv is probably what we want. .csv. We'd like to, do we have a CSV statement here, or just have to write it myself? .csv. Okay, so I'm just storing it now as a .csv file. Okay, so if I move to my compiler now, okay, compiler, I'm going to open ANSI C. Let's open my ANSI C compiler. Okay, so I have my ANSI C compiler. First of all, let's compile the other GCC MG5PTR dot. Okay, minus C minus wall MG5PTR dot C. Oh, it's not MG4. Oops. Huh? What did I call? Huh? I called it I called it MO file. Save as MG4. Okay, sorry. MG5 pointer.c. Okay. Make sure I have the same name. Hello, Carlos. So I'm gonna. Okay. All right. So I've got a couple errors here. I'm surprised. Okay. Average. Not AVG. Where do I have T mean? Oh, missing. Did not copy this guy. Okay, get that extra point there. Control C. All right, works out okay. O.exe mg5ptr.o. Okay, so now I have my program. I can look at my input codes and start to run the program. MGM, okay, input X, 3, comma, 0.78. Remember, when we did it, we have to have the exact same format. We suggest we wanted it input x comma t, next x comma t, 6 comma 1.11. Okay, and then it outputs the first number. Okay, so this is a program. So each time we want to do a calculation, we have to start the program again, right? This does not make too much sense. That's why we want to put in a while loop so that we don't have to keep doing that each time. So in other words, the UML for our new while loop is going to look something like, if I go back, let's go back to this guy again. Back to our UML way back, and we looked at our UML way back here. And we want to put that into, I put it in a download save, okay. And then I'm gonna, okay, downloads. So in this case, rather than read, so right now, this is the program we're using. This guy right here, right? We're reading X1, we're reading X2, T2, we're calculating the average, we're saving it, and we're ending the program. Okay, that's not a very efficient way of doing it because we have to enter X1 and T1 each time, right? We have to enter each time twice. So it's much more simpler if we just say, okay, if there's more data, we want to keep running. Okay, and we don't really need to do, we don't have to read X1 and T2 again because we know that the previous X2 is going to be the next X1, right? For the next one that we want to calculate. So we can just do it in here. Read X1, T1, read X2, T2. Okay, then go into the if something happens, stop. T average, X1 equals X2, T1, T2, read X2, X1, again, check if T is less than 0. If I've inputted at T2 less than 0, stop, continue. So we're going to be looping something like this around. So this is basically a classic while loop, right? So we would like a while loop here. So that's what we're going to try to do now is to build this, convert this code. Where's my code? Sorry, code, where are you? I want to get back to you. I want this code. So when you download, please, and we're going to put this guy in front so you know what you're doing. You're going to modify this with a while loop so that you can use this sort of thing. So you're going to read, but you're going to have to put a while loop in here so that we don't have to, and you're going to stop if T is less than 0. Okay? So when you want to stop the program, you just type in like some number and then -1, right? And then we know T is less than 0. That means the program's finished and we don't do any more calculations. Okay, so we're going to give you some time to work on that. Okay, if there's any questions, please ask, and I'll try to make sure Carlos is functioning correctly here, and then we'll let you guys all start working. Okay, is that clear, Ansari? Is that clear? Who else is online right now? We got 4 of us online. Okay. Okay.
Yes, but I'm unable.
You can't do it, right? Because your computer's not working, right? Okay. Other people okay? Actually, doing one more person online. Hello. Okay. Okay. All right. I'll try. Okay. So if you have any questions, please tell me. I'll sort of walk around and see how these guys are doing here. Okay. Okay. How are you doing, Carlos?
I finished my installation and can hear.
Exhausted. Okay. Hi. Okay. So all right. So let's. Okay. So you need to first of all get this stuff right. Okay. So what I've done now to try to make it more simpler for people is to you go to our web. I have a website now. I put everything on the website.
You mean your cell phone?
No, I didn't put it on Shell, so I put it on another book I published website. www. SDBA.info. Okay. Okay, so, all right. So this is the, now, obviously don't, okay, where do you want to go? Let's go here, select to go to where we want to go. you want to go basic concepts. So the book starts here, but this is for the basic concepts is what I put here. I start this section here, basic concepts. Okay, so this is basically everything we're doing in our class. These are the 3 examples we're working at. So the code we want to modify right now is keep going down, keep going down. We're trying to go from a pointer version to one that includes repetition. So we want to download this code right here. Okay, you can then copy and paste it into Notepad+. Okay, so that's the code we're going to be modifying to use while loops. Say whatever you want to call it. Maybe you want to call it what loop or something that's going to be loop when you finish it. So it's an SDBA, good, okay. You're doing okay?
Yeah, but the new is just UML diagram. Where is that?
Where's that guy?
Yeah.
Oh, the UML, okay, I can show you what that is. That's way up at the top, MG UML. Here. Yeah, you have to download the program to open it. If you don't have the program to open it, you're not going to be able to open it. That's in, okay, I didn't put it in this set. I put it in the, if you go back to the home page of SDBA, click down, install it. Yeah, you have to install everything, yes, okay. So the first one is to download these, the Flash player to allow you to view it. It's too small. On the other hand, maybe we can just put it on this computer, then you can use your computer and look at this one for the video, for the video, right? Okay, I'll work on that. I'll put this on this guy now, and you'll have a second one to look at. Yeah, that will screen is much easier. Let's just sort of stop. Maybe Carlos would find it easier if you were working here. Well, then you can look at the view graphs on one screen and do your programming on your own screen. It might be less confusing. Okay, I don't know, whatever, okay. Okay. Okay, extraction is completed. Exit, okay, great. Next.
So I copy it, and what should I do right now?
You're wanting to implement loops, while loop, a while loop.
Yeah, a while loop.
The idea being right now, let me first go get this guy functioning, okay? I think I've got to come. Okay, where do you want to go? I want to style. Okay, first I got to download this thing. Okay, make sure it's right here. We'll do SDBA. But it doesn't have to be, it can be wherever you want. But I just put it here because I don't want anybody else to delete it on this computer. This is not my computer, right? So if someone else goes and deletes it, it'll be some troublesome. Okay, and then I'll go to next. I want to go to basic concept. Okay, let's go to the UML. Keep showing folders. Okay. Now I have to tell it how to do properties, change, more apps, no, change, more apps, look for another app. Now it was in the programs, SDBA, okay, there, now it's going to always open with this guy. I like this there's another one that will open it, but it makes the images small. Did I, huh? I didn't download the right one, right? No. That's, okay, that's done, UML, okay. Different, okay, good, okay. Okay, there's the first, so this is the program we have now. This is the program we want to have. Okay, good, okay. Okay, that should be quite clear, yeah.
Yeah, it's not that.
And what font size are you using on your, okay, your font size is picking up, okay, so there's, okay, good, okay. So, okay, close that, yeah, we close it here. All right, yeah, just concentrate on that right now, yeah. Okay, good, okay, and we'll get across to make sure Carlos is okay. Okay. All right, please, okay. Oh, great, oh, good job, okay. Wow, okay, right, yeah, that's one way of doing it, okay. Well, why don't you increase the font size?
We are creating the while and the while loop, right?
You want a while loop, so basically you want a while loop in the main program.
We're going for
This
one,
yes.
and while is meaning right here.
This is the while loop right here, yes. This is the while loop, right? There's a any condition check. This is the UML of a while loop, okay? So in other words, you don't want to touch, so in other words, this has to be done in your main program. The while loop should be in the main program, right? Because the read is a subroutine, right? The calculation is a subroutine. These things are all going to be in the main okay, so all these things are going to be in the loop. Okay, so basically you're going to have to print inside the loop too, right? So basically you're going to have a whole bunch of stuff in this loop, right? The loop is going to be in the main program, right? And you're going to try to be looping it. But how are you going to be? You're going to have to keep getting the next x, y, x, y, x, y. You're going to have to add a statement here to make x1 equals x2 after you finish doing the calculation
Okay.
and save it. So that's going to be the end part of the loop. So yeah, so loop will go in the main program.
So, or okay. Okay, the only things I have to do is plus x1 to x2 right here in the while loop, right?
Yeah, that's going to be inside the while loop. So that doesn't have to be added. You're going to have to put it while loop in there. Yes. So yeah. Okay. All right. Okay. So just a sec. Okay. What's the? Yeah. And here's a handout. Here's some handouts to basically show what we're doing. We're trying to move through pretty quickly on this, but this would usually take much longer. Okay. So avoiding repetition around these numbers. 4, 5, 6. I'm trying to work on this. Okay, this is some of the key ideas that we're trying to do here and why we're trying to move. Okay? Okay, so first of all, your basic 7.1 is what we're doing. And then the other part explains why we want to do that. Okay? All right. But 7.1 is what we're trying to do right now. Okay? And then that's yours. So this is this lower avoiding repetition, simplifying and process. Okay. Okay. Okay, are you guys, do you understand what you guys are, anybody else, you guys online okay? Or not, okay, not an answer, you cannot do anything, okay, sorry about that. Okay. What do I do with that other thing? One more piece of paper, shoot. Where did I put that? Okay, Mr. Bao is here in person. The object is here. Sarfars is here. Ali is not. Not is not. Okay, answer is incognito. Rahim is here. Okay. Rahim, can you share your screen? What's happening with you? How are you? How's your progress?
I'm just doing it, Professor. It will take me 5 minutes.
Okay, sure.
Hello, Professor.
Are you? Yes.
Uh, I'm, I need to do. This is what I have done. Can I share my screen now?
Sure. Yes. Okay. Yep. Please.
So the change in code that I have done is I have put a do while loop.
Okay.
This is the
Okay.
only change I have done.
All right. Okay. Um, looks okay. Now let's start. Okay. So, all right. So did you compile it? Okay. Let's
Yes,
go.
I
Okay. Let's
did.
start. Okay.
But in your data set, you said and that mm, this will be the terminating input, right?
Yes.
-1 and -1.
Right.
Uh, but then I'm not able to understand what condition I should give, because if I put -1 it will keep on doing it again. But if I put -2 since the answer is -1.5, then it stops working.
Um, okay. So there's some problem with your loop, right? Okay. Let's go back
Yes.
to what's the problem with the loop. Okay. Let's try to look and see what's happening with the loop, your loop. Okay. So you're reading X1 and Y2. So that does not correspond to our UML, right? In our UML, we don't read X1 again, right? We only read Y1, Y2. The whole purpose is so you don't have to type in the numbers twice, right?
Okay. Yes.
For you, for
Previous. Okay.
each calculation, you're going to have to type in the number X1, Y2, Y2, Y2. The next time you're going to have to type in the same number to get the next one, right?
Yes.
So that's going to waste a little bit of effort. So the loop should not be starting with the x, y1, t1, t2. You shouldn't have to
Okay.
type that a second time, right? The loop should be starting a little bit later, right? And what you have to do according to this, we have to set, after you save the things, then you want to put the value of x2 into x1 and the value of t2 into t1 and then start the next calculation.
Can you repeat again,
So you
Professor?
see what I'm saying? Right now, if you are trying to do the calculation, okay, let's look at the okay, you see my my dev file, right? That I have here.
Yes.
Okay, you see my screen, right? Can you see my screen?
No,
Yes?
I will stop sharing then.
Okay, sorry, no, okay. All right. Okay. So the problem I see here for you is right now is if you every time you want to calculate the velocity between these 2 points, for example. Okay, sorry, for these 2 points, you have to type in this point and then this point, right?
Yes.
Correct? Then when you want from this point to this point, you have to type in 6 and 11 one more time, right?
Yes.
And then next time you have to type in 9 and 12. So you have to, and each data point you have to type in twice.
Okay.
The way you have written the code, right? Do you see that?
Yes.
So you don't want, that is extra work. You would prefer not to have to type in the data twice, right? Doesn't make any sense,
Yes,
right?
yes.
To have to do that way. So yeah, so I suggest you, so try to make the modifications so you don't have to type in the data twice.
Okay.
Okay, so you're going to try to do this. So that's what this code is trying to do. After you save, you put the value, in the program, you copy the value of x2 into x1, t2, and then you only have to read x2, t2 this time.
Okay. Understood.
Okay, so okay, try to make
Yes.
those modifications and okay, and then we'll look at your screen again. Okay, sounds good.
Okay, Professor. Yes.
Good. Okay. Wow. Okay, t is greater than 0, comma 0. How can, what's a comma? T is greater than 0. Well, I mean,
Oh, 0.0.
yeah, not a 0, comma. I mean, that's a French decimal point, but we're not, the programming is not in French.
Okay.
0.0, okay?
We're not going to do this.
But t, which t? You don't have any variable t. Is it t1 or t?
I'm going to put our t my side.
Oh, okay, right, okay, fair enough. Okay, good, okay. Okay, oh, okay, right, okay.
So that when you're just going through complications. So 吴老师每个人吴老师我们比较的as I know okay is going to
Okay. Okay. Okay, so x1 is equal to x2, then you're not going to have to, actually, okay, if x1 equals x2, why you got this all up here already? Why do you want to put it 2 times? Here, if everything's in the loop, right?
Yeah.
Read, it's only reader outside the loop.
No, dude,
But the dy, dt, and t are not outside the loop. Okay, maybe you want to make it if t2 is, or you can say if t2 is greater than 0. Well, t2 is greater than 0, then you don't have to worry about using t. Right, yeah. Then you can put all that stuff inside the loop. You don't have to worry about putting that stuff outside the loop. Yeah, you understand that constituting the loop, right? Oh, not to get extra t though. Right, because you have to have something when you come in or it won't be any t2. So you gotta at least do that first once, okay? Okay, now you can calculate the derivative, right? The next step is you read that, check. then calculate. The next step in the UML are these two statements, right?
These two statements right here, right?
No, but they're right here, but now you got another get x, get t before them. Why do you have another get x, get t here? You haven't done any calculations yet.
Oh, so this one is putting inside here.
Yeah, that's at the end, yeah.
This one I'm too confused.
Okay. All right, good. But you've already got t1 equal t2, so you don't have to get t1 again, right? You only have to get t2. Yeah. Oh, you already got t2, getting it right there. That line's not even needed. Okay. Right? Okay. All right. And remember, you want to print it before you get the next value, right?
This one, this one is green.
Right?
This one is green.
That's print, right?
Yeah.
Yeah, you can print it there. That's okay to print it there too.
Yeah.
Okay, all right, okay. So that's okay, maybe I'll use the wind velocity.
Why Windows 7 is so? I just opened it a little bit.
Yes, it's okay. The window, the door should be okay now. The door is closed more, so hopefully it's much cleaner. It's not correct. We do that, yes, okay. And I can use this also to help me ensure the door does not get too far open. That will keep the wind at a good speed. Okay, great. Okay, our.
Yeah, I should try this one, and I'll know where.
Find the errors.
Should we close this?
It's okay, it's not that much.
Really?
As you like. I'm very happy. Okay. All right, how are you? Okay. Well, T1 is less than 0. No, well, T1 is greater than 0. Greater than minus 1. Remember, minus 1 is when you stop. So it won't, no, if you got less than, it means it has to be less than 0. And to run. So you want it to be bigger than minus 1 to run, right? Minus 1 is the stop, so it's got to be bigger than minus 1. Yeah, okay, that looks okay then, okay? Okay. Okay, that may look reasonable, okay? You don't have to, yeah, you don't have to change any of the functions. It's all in the main code that you have to do the changes, okay? So you should try to compile it, see if it's compiled okay. And see if there's any errors, and it'll show you any error. You'll find errors, I'm sure. We always do. Okay. Let's see, okay, we'll only look at the first one. CWA C30 number 2. C30 line 31. You didn't change anything down here, did you? Okay, that looks okay. All right. Okay, what's the problem? Oh, you already fixed it.
No, I fixed it.
Okay, good. All right, continue. Okay, this time let's what area now? Okay. Okay, average is undeclared. Double average, return average.
First this function.
Yeah.
We have no AUG before.
Is this do you have Chinese? Is this a Chinese something in Chinese and not in English? Sometimes you have a Chinese. That's an English. Oh, that's in English. It should be okay. Oh, okay. Oh, you never saved it.
Oh. That's not
Okay.
in name here. Under numbers
Why do you have an X?
Huh?
Why do you call it an X suddenly?
What?
In your program, you're calling it Y,
Oh.
and now suddenly change its name to X.
I.
Okay, all right, yeah, in my UML, I used X, right?
Yeah. Sorry. It's my fault.
In the program, we use this, and it just meant a variable. Okay, fair enough. Okay, that should be look okay. Save, please make sure to save, yes. It helps. Okay, it compiles okay.
GCC. Oh.
Not the dot, mine is gold.
Mine's. Let's do it.
Or I shouldn't say mine, hash dash, oh, okay, yeah. All right now. Okay, good. Okay, so we have some X's and T's you can try to input, right? To test 0, 0, 3, and
0.
0.
Should I put dot?
Doesn't matter. Can it or not? It's okay. Probably better to put the dot, yes.
Or I should put comma.
Yeah, the comma for sure. And
3, 4, 0, 1, 6, 8.
all right.
Okay, I didn't put it out.
Oh, because you got another what? Why do we have another? Hang on. Okay, before you print, you get another get XT here. So you want to print this stuff before you
Oh.
when you do after you do the calculation before you get something else you want. Well, the print. Yeah, the print should probably be earlier, right? Now you're trying to get more data before you print anything.
Oh. Oh yeah.
You got another get XT there. Okay, so why don't you first I would say just try print it first. You're still okay. All right, fair enough. Okay.
That was okay?
Yeah.
Oh, that's really good.
You can put it even further up, right? According to the UML, it should be further up, right?
Yeah. I'm so confused. Sorry.
What do you mean confused? You understand? Do you understand why? Look. Okay, never mind. Look at your UML. Okay, sorry. I'll stop the flying. Flying paper. Okay, never mind. We'll switch back to get rid of my picture or the flying paper. That's courtesy of I try to okay no more flying paper. Okay. Okay. Rahim, how are you? How's it going?
I have done it.
Okay, can we look at your code then? You want to share your screen?
Sure.
Okay. Okay. Okay, good. All right, looks okay. Do you want to run the code? Okay, good. And then next. Okay, can do. Okay, good. It looks like it's running good. Okay, all right, good. Okay.
And now if I will input -1 because I have put the condition while t2 is greater than 0. If I put any
Okay.
negative time, the loop will stop.
Okay, let's see. Well, we'll stop. Okay, let's see. Next. Once you do that, okay, we'll continue this one, and then we'll do a negative time. Okay.
Okay.
Okay, good. 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 Okay, Okay, good. All right, loop stop. One extra value that's sort of strange, but then the loop stops. Good. All right. All right. Okay. Fair enough.
Since it
Okay,
is a
good.
do while loop, it will print something.
Yeah. Correct. Okay. All right. So, okay, that's fair enough. Okay, good. If you're getting the key ideas working, okay, fair enough. Okay, good. All right. We'll just okay. So you can take a short break, and then we'll continue on as soon as everybody else gets that done. We'll continue on. Okay.
Okay.
All right. Good. Okay. You're okay. Okay. Let's see. Oh, it's Carlos. Okay, it's working okay? No? All right, let's see, okay.
Brains and that makes it easy.
Okay, what happens, okay.
Oh, it's not. I have to open it again.
Yeah. Am I sharing, what am I doing sharing that? Fire hydrant, okay. That's not what I'm supposed to be sharing. Okay, let's try getting back to my screen. Okay. Mhm. Okay. Input a number.
Stop again.
Okay, change to 1, 2.
It's stuck right here.
Well, T2.
Because they tell me I'm going to get the XT, going to get XT here.
Okay, T2 is greater than 0. Okay. Okay, let's control. Okay, I stopped. Okay, I'm gonna try to run home. C W D, enter. Okay, let's sit 4, 7, 5, 9.
Yeah, it's not about. It's about the wire. It's stuck in the wire.
Why is it? Okay, okay. All right, so let's control. Next, okay. Control C. Let's compile it again. And we will minus G. Okay. Okay. There's a the while loop is not a while loop. See, it's giving you the error. The while loop. Now the warning tells you there's a problem with the while loop. The while.
The wire is not a wire loop.
That's not a while loop. It's got a semicolon after it, right?
So,
So the while loop is staying here.
oh.
It never goes past this line. It keeps saying, well, T2 is greater than 0. Is T2 greater than 0? Yes, stay here. Is T2 greater than 0? Yes, stay here. T2 greater than 0, stay. Okay.
Oh God.
Okay. So you're very good at finding out where it is. Okay. But you can see how the this warning message in minus G flag help will give you some more information on finding it, right?
Oh, this one. Orange.
Oh, it's saying that this is misleading because it's not in the while loop. It thinks that you want the while loop to stay on that one line, and it's saying it looks strange, you should indent it because it's not in the while loop.
Oh.
Okay, let's try to compile, let's try again, okay. Good. Down. Down arrow.
No, up, down, up.
There it is. correction page. Yeah, I think for programming, you have to keep making small mistakes and slowly realize. If you just look at a textbook, it's no use.
Systems like work.
Pardon?
Systems like work.
Okay. How are you doing, Milton? Oh, it's working? Okay, good. All right.
Why?
Good. Working? Okay, good. Working, okay.
And the -1 and -1 is something.
Yeah, -1, -1.
Do you have any of
What? Ideally, if you had nice programming, it wouldn't, but the way, probably the way you did your while is not quite the way we did it in our loop, right? If you look at your program, look at your program. It first, yeah, so you entered, yeah, you get your, yeah, right, because, yeah, so you only get to next, so it's y2 is negative, you enter the negative, but it still doesn't calculate it. And then the only real n equals t1 negative, only when it comes through the next time. Okay, minor problem, minor. That would be very sloppy. No, don't do something like that. That's very sloppy programming. We don't program like that. You would have to put an extra get right in front of here. Put an extra one there. Yeah, no, break, no, the get will go there. This get will go to outside, and it gets repeated at the very end. Yeah, because you need one inside too, right? Right? Okay, and now it's T2. Okay, P2, not TT. Okay, all right, good. All right, now, as soon as you enter T2, it'll check to see if it's minus, that's the minus. Yeah, and then it will drop out, it won't do an extra line. So, yeah, don't do funny things like breaks and things like that. Please, we're doing structured programming. If you start breaking stuff, it makes things very difficult to read or understand. Okay, so we'll break for about 3 minutes, okay? Okay, because the other two people are all finished, so, okay. We will start again in 3 minutes. So according to my watch, it will be 1:13. 1:13 in the meeting time. And okay, did I give you the paper? Yeah, you got the paper. Good. Okay.
Good evening, Professor.
Pardon? We'll be back in about 2 minutes now. In 2 more minutes, we'll start again.
Yes, it's me, Rene, Professor. Sorry, I couldn't.
Oh, Rene, you're on. Oh, Rene, you're here.
I had an
Okay.
accident earlier. A motorcycle accident.
Oh, I'm sorry.
Yeah, I'm heading
So
to the
where
hospital.
are you now, Rene?
I'm still in Indonesia. I'm waiting for an embassy. Hopefully by Monday or Tuesday, they will contact me to.
Okay, so
go
it's not
there.
a Taiwan hospital. It's a Indonesian hospital. Okay.
Yeah.
Okay. All right.
Yes.
So okay. Welcome, Rene. I wonder what happened. I wondered. Okay, I thought you might have been flying. Okay.
No,
Not yet.
not yet.
Not yet. Okay. So, as you can see, we're basically doing the moving from pointers to loops today. And this is our first example. Okay. Are you? So where are you hurt?
Yeah. A little bit. I'm going to the hospital to get it stitched.
Oh, okay. Oh.
Yeah.
Well, my son had an accident the other day too, but not actually in the bus. The bus suddenly stopped and he got thrown forwards too, so he went to the hospital for stitches too.
Yeah.
But okay, so your leg, arm, or
Oh, it's my leg.
leg? Okay.
Yeah. I just had a little bit of bandage on it, so I'm heading to the hospital to get it all
Ouch.
fixed.
Oh, okay. I see. Okay, so you're not at hospital yet.
Not yet. I'm about to leave.
Oh, okay.
Yeah.
Okay, yeah. That can be priority. Okay, I
Yeah.
got you. Okay,
I'll
priority.
download the video. I'll download the video after the class and follow the class.
Okay, fair enough.
Yeah.
Okay, good.
Thank you very much for
All right. Okay. Okay, so we'll start back again what we're doing. Okay, all right. So this is the data file we want to use. So we did this programming. Okay, I'll write the program myself here, quickly make the changes. While, right? T2 is greater than minus 0.9. Okay, just in case, because it's very sort of dangerous to try to do things too close. Okay, we're going to run this, calculate this, print this. Oh, good grief. Internet connection has got problem. Are you guys can hear me? Hello?
Yes, we can.
Yes,
I
Professor, I can hear you.
Okay, good. It's got a warning here saying that you might not be able to hear me. Okay, you can. That's good. Okay. All right. So I got my while loop here. Back to my, this guy says I need, let's move this, make this thing smaller. Put this on this side. Okay, put this guy, my code on this side. Okay, fair enough. All right. So I've got my loop here. I'm printing it. That's good. Then just as you said, T1 equals T2, Y1 equals Y2, and finally, so that's what we wanted. So I've got the save, I've got this line, then I'm going to have to read one more, according to my UML, I'm going to read it one more time, so I need this read again. So the UML is very important. It tells us basically what we want to do. So now if I look at my UML, read x1, xt1. Okay, good. Read x2, t2. Good. Stop condition. Yes. Stop condition. Yes. Calculate derivative. Yes. Calculate mean. Yes. Save data. Yes. T1 equals T2. Y1, Y2 equals X. Okay. Yes. Read again. Yes. Okay, and then my loop ends. Okay, so you can see this is very closely following the UML, right? If we look at our UML, we basically are trying to put one, as you can see, I'm trying to do it with one line per bubble. Okay, so, and let's save it. Okay, and then I'm going to go to start to compile. Now, GCC minus wall. Okay, was it M5? I saved as M5, yes. M, okay. So M, input X and T, okay. We've got that, okay. 3, 6, 5, 7. Okay, okay. Okay, 5, 6, okay, sorry, whoops. -1, -1, stop, okay. All right. Now, why am I trying to do this way? What other advantages does this loop have? Well, you know, I just created this file, this guy, right? I can put, my first line should be 0, 0, right? 0, 0.0, comma, 0, 0.0. Okay, I'll put that as my first line, okay? Make it nice in format. Okay, so there's my... Hello? Yes, question?
Sorry.
Okay.
Yeah.
Okay, sorry. Okay, no problem. Okay, so there's my, this is a data file, okay, with all my data in. Now, one thing that is, okay, now I want to run my program AM, and I'm using, when I run the line program, I can use input redirect. This little symbol for Linux or for Windows says, take standard in from the file name I'm giving you. So my standard in is now dxdy.csv. dy.csv. Okay? All right. Now it's going to take the input from this file. Okay? And I can just watch, I can run it. Okay, and there's all the output. 3, 9. It did all the calculations. Now it just reads line by line. Now, if I'm doing that, I probably don't want to, let's go back to my program again. Probably I don't want to do an F print anymore. I'll just stroke this out. Okay, get rid of this, right? I just want to read the numbers because if I'm reading from a file, I don't need a prompt, right? I don't need to ask for it. So let's quickly recompile that. And I can run it. Okay, just process the whole file. Okay, now let's say that's not that useful for me yet. So I can do this as an output redirect. I can now redirect the output to say velocity point CSV. Okay? So in other words, I'm not going to put it to the screen anymore. I'm going to put it into a file velocity.csv. Okay? You see we're going to practice this in a second. Okay? Okay, nothing goes to the screen. And I can just type veloc.csv. If I type veloc.csv, what's going to happen? It's just going to, okay, in my program, it opens with JEdit. Okay, I can open the file with JEdit and see the file. Or you can see what happens when you type vel.csv, what happens. Okay, if you do that. Okay, please practice this on your own. Make sure you have this file. Download the file from the website. Okay, this little guy with the data file, and then run it. Use this sort of way of running through with the input redirect and output redirect. So this is how we can handle doing files very simply. Okay, let's check with you, Carlos. Okay. Okay, let's make sure. Okay. SDDA, not SDDA, Structured Data Building Algorithm. Not site, go. Go. All right, okay, so you want
this one.
Yes. Cover the whole file. In the same directory, yep. Make a new file, yep.
Where's my mouse? I couldn't go right here. I don't know why.
I see the cursor. I don't see your mouse.
Yeah, I can see it too. Why? Whatever. I put it right here. Back. Never do it in face.
Okay. Save this.
What's going on?
Anything you want. Just something .csv. Anything .csv. Anything you want. A.csv. .csv. .csv.
Really? Should I put it right here?
It's a normal text file, yes, correct. No, you don't have to change anything there. It's just telling you that it's a normal text file you're saving. That's what you want to save. You don't want to save anything unnormal. Because you could save it as, if it was Chinese, you couldn't save it as a normal text file. Okay, now we'll go back to it. Where you, Now, back to your, where's your, okay, NCC, good. All right, now you can run the program with that as your NCC. A. Yeah, CWA is the name, right? Huh? No, .exe, isn't it? Hello.
Hello.
Welcome to class.
What?
Hello.
Hello. May I come in?
Yes, you may come in.
I can't open the door.
Oh, you cannot open the door, sorry. Okay. My apologies. Okay, all right, okay, great.
Okay.
Welcome.
Okay. It's quite. Maybe you can sit here.
Pardon?
You can sit here if you want.
Oh,
So what's wrong? Why you're there?
this is the, I can see everyone when I'm teaching and the people online.
Okay. That's nice.
So I can see it, that's why I'm sort of sitting here. Okay, let's see, how is your program going, okay? Okay? Huh? You don't have any input. You forgot to put the input redirect, you just typed NG4, right? And now it's waiting for some input. Okay, let's try, 3, 4, 5, 6. Okay, 45, 3, minus 1, minus 1. You disabled the prompt, right? So now it's, and you're telling it's back to standard input. Here it's getting standard out. You remember you didn't, if you wanted to read from there, you gotta type, where is it? There it is, right? You wanna type this, you gotta tell where to get the data from. You gotta tell where to get the data from there now you can, now send it to standard output. You need another arrow, yes. Okay, now type MA. Oh, MA.csv, try MA.csv, MA.csv, sorry.
What you guys have the mask inside? Open?
Let's see, what it did open anyway, should have opened somewhere.
Not like.
It doesn't give you a warning, what did it do? What did it open? There it is, open it, there it is. In Microsoft Excel. Yeah, this takes some time, right? Okay, so MA, so right now your computer is programmed to open .csv file with Microsoft Excel.
Yeah.
My computer is programmed to open it with JM. Or other type people, maybe Cal, might be another program. So whatever you set it to open that file. So, but this will allow you, now you can quickly graph the velocity, right? You can use Excel now to do the graph. Like both lines, both, you select both. Okay, and then sharp, insert, I think it's insert sharp, right? Yeah, it's one of these guys. You want to just oops. Oh, is it yours? Okay.
Well,
So I didn't try to read
sorry for that. Oh, really? I thought that's Paula's.
I just work on like that.
Okay, all right, okay. Okay, just a minute, okay, well, your computer will recover after our,
I thought this one is yours, right?
Yes.
This one is yours.
Yes.
Okay, wait. I will take it out. This adapter is yours?
Yes.
Okay. Wait, I will take it out. You got this thing.
powering this,
This thing.
powering
In my computer terminal.
this everything. Okay, you can use this bar if you want it closer to you. Nobody else will be monitoring it. Okay, all right, okay, so it's yours,
Sorry, sorry.
Is it working now?
okay, all right.
Working, right?
CW data, okay, did you, okay, but what if we got out, okay, let's look at that CW data CSV. Okay. Okay, all right, but basically you should probably get rid of this input stuff. Okay, so go back to your code.
Oh, you mean?
Yeah, because you're going out inputting, yeah, you want to get rid of that line, right? You already did, okay, good.
I didn't say because I
Okay, all right, yeah, okay. Have you seen Ali? No? Okay, okay. All right, okay. Okay.
Professor,
Yes? Yeah,
Ali is in Taipei.
he's in Taipei.
Yes,
Oh,
yes.
okay. All right. Oh, okay. You saw Ali in Taipei?
No, he
Okay.
messaged me last time.
All right. Okay. Oh, he's in Taipei. Okay. Fair enough. Okay. Then he's obviously not here then. Okay.
What is he doing in that?
I have no idea. Oh, yeah. Okay. The other day he was in Tainan. So he's moving all over Taiwan. Okay.
Oh, yeah, he's on a trip for a holiday.
All right. Okay, good. Okay. So I think everybody's got that working. So that's one way in which we can do a lot of data processing. If we have a lot of data coming in, we can read the CSV file with data in it, process it to another file, and the advantage of not using arrays and doing it with these simple structures is it doesn't matter how long the file is. We're not going to have any problem with memory. If you try to load everything into an array or something, you may have some memory trouble if the file is too big. So for example, Ali is working on very large files. So if he tries to use arrays, it will crash the program. Okay, so he's already seen that a few times. Sometimes if he tries to do too big a data thing, that program's not going to work. So that's, you have to make sure the data can maintain your memory. This way allows you to do a small file and just keeps it very small. It doesn't take much room. All right. Okay, we've looked at this guy. Let's look at another example.
Professor,
Am I sharing my screen?
Professor,
Am I sharing a screen? Yes.
I need to ask something. Can you show the code again?
Okay, sure. Where did my code go? Okay, yes. All right.
Why is the condition T2 greater than minus 0.9?
Oh, because if I do greater than -1, right? It's kind of, if I type in -1, it may not be greater than -1, right? If I type in -1 to end the program, right?
Yes.
These are double. So
Yeah.
the number I type in is not going to be stored exactly as -1.
Okay.
Do you understand what I mean? It's going to be -1. It's going to store -1 plus or minus 1 times 10 to the -23. So if
Okay,
it happens
okay.
to store on the wrong side, my program won't end. So it's much safer to do this, 0.9.
Okay, understood.
Then you definitely know it's going to be greater than -0.9. If it's -1, it's definitely going to be less than -0.9.
Yes, yes.
Okay.
And also, can't we put the while loop before we are asking for y2 and t2? Yeah,
If
just
I
like
put it right, okay. If I put the while loop, good question. I thought of that too before. So if I put my while loop here, the
yes,
big problem is the first time the loop runs, I haven't asked for T2 yet. Okay.
yes.
So a simple way, yes, we could, if we say T2 equals 6.0. Okay.
Okay.
Now T2 is, I can do it then I can do it this way, right? Yes. And I can
It
get rid of
needs
this
to be
statement.
predefined.
Yeah. So as long as I define T2 as being greater than, or I initialize everything as 0, right? If I initialize T2 as 0, it's also okay, right?
It's also,
Initialize everything.
yes.
Yeah, it would
Yes.
also work okay, as long as I initialize. So this is probably a better way of doing it. You're right. That way I don't repeat this statement. Yeah. So I would
Yes.
say doing the code that way is better than the way I wrote it.
Okay.
Okay, I agree with you. Okay, Tangi, Rahim, I agree with you. This is a better way of writing it than the way I wrote it.
Okay. Thank you,
Okay,
Professor.
good. Thank you. So you see why this is better? You understand why this is better, Carlos?
Yeah.
Because I can avoid one statement, right? I don't have to write get xt2 twice. the way Raheem is doing it, I'm saving, having one extra I make the code a little bit shorter and more clearer, right? I don't get T2 inside and outside the same statement. I just only have one time getting that. All right. Okay, okay, so we're way down here talking about moving to, okay, we've used pointers, we're talking about flow. The conditional, we tried to fix the lens equation first. We did that already. Now, let's try, what we want to do now is to change the lens equation now to do multiple lenses. Okay, right now, our program, okay, let's look at our program right now. If I look at here, it's our current code is input 0f. Basically, with m equals 1, we find image position, we find magnification, we print, we stop. We basically do one lens. Now what we'd like to do is, okay, let's do a few lenses. So that will be, let's look at this guy, download him, keep, show on folder. Okay, we've done the simple lens equation. Okay, so let's go. So there's a simple lens equation. We entered all this stuff. For multiple lenses, we've got to put this into a loop, right? We need to have the prior image is going to be the input, as well as the next lens. We're going to calculate objects. We're going to calculate the thin lens, use the thin lens equation, put the back into our coordinate system, calculate the image height, output this. Okay, in one lens, we only do this once. If it's multiple lenses, we're going to start to repeat again, right? This was the one lens case. This is going to now repeat. Do I have my picture here? First lens. Okay, for our repeating, we're going to have a repeat here, and we'll stop if the focal length is equal to 0, right? So we're just going to put in our repeat here to our lens equation. Okay, we're going to add repetition. All right. So this is what. Oh, hang on. I'm not very helpful. I'm not even showing the screen, right?
Yep.
Ah, that was kind of pointless. Okay. Okay. This is basically what we've got right now. This is the code we currently are using. We're inputting the image position and its height. Its x coordinate, its height. We're inputting the position of the lens and its focal length. We then calculate O for the thin lens equation. We use the thin lens equation to get the image location. We then move the image I, we put it back into our coordinate system, so we know the position, and we also calculate the image height. So that's what we're doing right now, and we're ending it, just one lens. Now, obviously, that's not very useful. In any system is multiple lenses. So here we can just add, once we've got this new image position, we can input the next lens. Okay, we have to make sure we need to input the next lens. We have to make sure our new object is going to be related to the last image. Convert get the object level from this image. Calculate the new image position, calculate the new I and X, and output this information, and continue on. Okay, so we're calculating. So so you understand what we're doing here. The initial object provides an image, and that image becomes the object for the next lens. So each time, that's how we're repeating, and our logic is working. Okay, so the code that we want to work with is the previous one, the mopt. Okay, we come down here, the one that we fixed before, right here. Actually, oh, okay, so it's going to be this guy, this code. So please copy this code, the MO6F. We'll copy that one in, and we'll try to make that into repetition. Okay, so that's the guy we want, is this code right here. Copy it, and we'll start to work on it. Okay, this guy, MO6F. Okay, so, and we'll work on that. our main thing is to try to create a looping program to loop it to do multiple lenses. Okay, again, can also be a while loop as well. Okay. Make sure everybody's okay. Nice to see you okay.
What time this class will get over?
9:30. Again, you're not going to play with any of the functions. It's all in the main code. So all changes should be in the main code, not in the functions. We've already done the basic functions, so we don't want to touch those. We just want to touch the main code. Pardon? Oh.
Because I just joined now.
Okay, sorry, okay. All right, keep going down. We're going to try to do them before we go into flow. We want to go through, okay, right here, this if one.
This one.
Yeah, that's what we're working on right now. The optics program, if. That's the one we use the if to try to help correct the problem with the image, right? Remember the last week we worked on trying to if O is less than 0 else. That part we put in there in the equation of the lens to make sure it's working correctly with one lens. So now we know it's working correctly with one lens. We're going to start to work with many lenses. Okay, Rahim, okay? You got the program we're working with?
Yes, Professor.
Good, okay. Did you find the parts we need? Okay, great. Look at that program. Get OLXF. Don't have that. No. How come your MOF is different than mine? Huh? Your get O. How come your get OL has got 4 things, not 2 things?
Oh, because this is the class for 5, is last.
Yeah, okay, so, yeah, but really, it's better to do, because this time we only need to, this time we need to get those 2, right?
Yeah.
But this time we only need to get F, we don't need to get I, so that's why it's better to have the 2 break it apart.
Oh, so, okay.
Right? Because last class was good, we could get it all because we're only doing one lens, right? Now because we're doing many lenses, we don't want to put it all in one. go down. Yes, there, right there. MO.
I thought it's the same.
Almost the same, except for that I got it 2 separate lines.
What?
But there. Okay. So now just getting the, and then getting the next position for next.
Oh.
Okay, good, yeah. Good. Right, that's basically where you want it, right? Oh, you want that? This is not.
I was looking at the
Done. Oh, okay, the UML, okay, UML is MO UML. There's a single lens, that's what we got. There's the revenue. Then we're moving into the wild check. 0, then quit. Yeah, you move back and forth, you see it. Okay, go back, this is the current code. The current code is this guy, right? It does all this and this and the new code, it doesn't end. It inputs LX and IF.
again.
It's why.
Yep.
Why they have 2 CIX?
Pardon? Why is
2 CIX.
redefinition of CIX?
Oh. 2 CIX.
How come we got it twice? They're the exact same. I don't know why the code is twice.
So I did it.
Delete it, yeah. No idea. How did that code get there twice? No, what is this? Oh. Well, LF, that doesn't say it. That you want to tap on L. Okay, what's this that code doing? That's putting 0 into LF.
This one?
Yeah, it's storing 0 into LF. It's not asking whether it's equal, it's storing 0 into LF.
Oh, no, they're.
And that's it, checking, that one's checking. The other one checked is T1, okay, that's putting 0, okay, now. So that's not the way you want to write that statement.
No, I'm going to stop the loop and.
But so that's putting 0 into LF. It says LF equals 0. Put 0 into container LF. Okay. All right. So how would I do that? I can't do it that way. Oh no, the while is okay. It's got to be while. But the way you write that has to be a bit different. Okay. I'll make sure. Okay, I can show you a quick way of doing it. Okay. Less than 0 point. Good. Point 0.00001.
Really?
And and you gotta have an and, double, one more of those, and is double, LF greater than minus 0.0001. Okay. Hello, welcome back. Okay. Okay, so see what this is doing now, let's check it. Is it less than this and greater than minus this?
It's almost zero.
It's almost zero.
Oh.
That's the safest way of doing it. Okay? Okay, because, so LF equals zero, says put zero into container LF. It doesn't say is LF equal to zero. It doesn't say that, no, it says put the value zero into the container
That is
LF.
not an definition, it's meaning I'm going to put the things inside.
Yes. Ah, not seeing if they're equal.
No. Too complicated.
Oh, what? You can understand why, because that symbol, that's what that symbol means, right?
Yeah, I know, I understand that. I try, and I didn't say
It's fine.
It's fine. I know that. I know my role. Let's try CTC. What's going on?
According to lens. Okay, good.
Yeah, go ahead, for example.
Optical. It's now optical. You're an optical now.
Oh,
You're now the optical one.
too far.
The optical example now. We should be somewhere here.
This one is fine, right?
Okay.
Putting their old expert.
Okay. Okay. There's a few examples. Okay. Object at 0, height 1. Object position 0.
0, fish 1.
Oops.
10.
F5. Yeah. Okay.
Okay, something wrong.
It only ran once.
Just get, and then another thing didn't work.
Oh, sorry, you got it backwards. It's LF greater than this.
Oh,
And or, not and, or. That's like, okay, sorry, it should be or, not and, okay. Double straight arrows. Double straight hit.
double.
Straight hit. No, not that. It's just, I think it's this key here. No, not. No. Try to put. How about shift in this thing?
Shift, yeah,
No, that's not shift.
that's shift.
Where is the straight line?
Wait a minute, I tried to change, to try to do that, try. See.
Yeah, that's it. That should work, okay.
See.
Okay. Next lens. What are you doing? What's all the 35? It's a series of lenses, right? You only type in the object position once. Everything else is lenses after that,
Oh.
right? Okay, but that's okay. So it's still working. It's still running. It's still running the image. So what it's saying is your first object is located at position 0, 1. Then you've got a lens at position 10 with a focal length of 5. Then next lens is position at 0 with a focal length of 1.
That
The
is so.
next lens is at location 35 with a focal point of 10, which gives you this huge. Okay, hang on. There's something happened. No, you don't want to get the object position again. Why are we bothering to get that again?
Oh, cause we only will gather, I'm missing.
So it should be now basically, okay,
Yeah, that basically you only have.
you
this
print
one.
that, and then you want to get that. Now your new OX is going to be the image. OX equals IX. OH equals IH. Right? Just like the previous case.
Yeah.
You gotta have a line right in here. Like your new OX equals your previous IX, right? IX, right? And your new H is going to be equal to your IH, okay? Remember the, okay,
Yeah.
okay, so you see what you're doing, right? In this idea is your previous image is going to be the object for the next lens. Okay, and then, okay, that's all this is.
And then it continues from here.
And they'll keep going, that's how basically something like Code 5 works, and all these expensive ray tracing programs work. You can reach the lens, but then they add a few extra things on too that will help you determine how many other things like scatter light and stuff like that, how much light is scattered and other things. But basically they're just doing this. Okay, finished. All right, okay, let's see. Okay. If your program is functioning.
We are doing here. What is the concept?
What is the concept?
Yes.
Okay, okay, sorry, all right, that's okay, Shazib. Oh, sorry, I didn't give you the object sheet. Okay, sorry, I gave you the object sheet. Okay, okay, yeah, I guess you pretty want to know what the, yeah, we should probably spend more time at the, okay, this is, okay, we're going down here, okay. Okay, it's not in that one. That's for the on, this is for ray tracing. Okay, okay, let's, I'll draw a picture then, okay, picture is easy to work with. All right, so.
So what? Do we have to return?
No. Hang on, I haven't decided that yet. Maybe, yeah, I gotta think about that, yeah. Or whether we'll just have a project. I can't remember, what did I write on the course evaluation? I can't remember what I wrote. There's no exam?
You tell me, yeah.
Okay, then it's a project, I think it's okay, can I look at what the for the course is? Okay, you guys probably read, okay, so this is the concept, okay, we've got this guy standing here, right? I've got a lens here, right? And this is the focal length here, I'm gonna get my object person like this, right? Okay, and so this now is the image, this is not a real person, this is the image. Now, but if I've got another lens, I can say this is now the object for this lens. So this now becomes the object for the second lens, and I'll get another image way out here.
This image seems to become an object for this.
Yes, and then this is the image for the second lens. So this is F. So this is F2's image. This will be F1's image. This is F1, but it's F2's object. This is F1's object. So that it gets transmitted straight through the system. Okay, so that's basically what we're trying to do here. So the previous version, we only had one lens. Okay, now in the new version, we're just adding repetition.
This also becomes input.
Yeah, this output is now the input object. The image is now the object for the next one, right? Okay. So the image of the previous one,
IX is
image,
IH
image height.
height.
Okay, so in this case, I'm just saying the image height. I only have to store, I can save one variable if I want. Because always I know this object is going to be image for the next guy. So I can pretend that this first object is actually the image of F0. This is F0's image, which is going to be F1's object. But there's no F0, right? Okay, so I'm just saying that this is F0's image, and I'm going to start with that and start to move through. Okay. Yeah, right, because then here we can say, okay, once you go for right, the input just that, okay, that's it, right, that's all you need to input, yes, good. Okay, and then you got, okay, good, and then you got to check there. The only thing that you forgot here is now you've got to make sure that you've got the, according to this code, right, you got to make sure that your next object is got to be the previous image, right? So you got to have a little code here, a line here, right? You remember, just like in the previous case with the CSV data coming in. Yeah, right? Yeah. Okay. No, I object, okay, OX comes in, right? Yeah. Equals, it was. Yes, equals the next sentence, right? So you want to store the value of IX into OX. And you also put the height too, right? No. Remember, if OX equals IX, it's got to be the new object height is going to be equal to the previous image height, right? Height, yes. Right. Yes, so you have the new object. Yeah. No, OH, there's no OH, right? Will become IH, the value that's stored in IH is going to be put into the container OH. No, you wrote it right. Your C code is right, it's just your words are wrong. Your English is wrong. Yeah, so right, we're putting.
Yes, image will be
Put
put
in
into
object.
yeah,
Yes, the image position is going to be put into the object position.
Image will become as
Yes.
object.
Right, yes. Right. So it's this way, not that way. Okay, now let's see the program compiled, and not there's any problem. Any trouble getting?
Yeah. Dead.
Okay,
That's all. Dead.
everything will go okay. Did we lost power or something? No. Okay. Your code's working okay, Carlos?
Yeah.
Okay. Your code should be okay, I think. Okay, so let's maybe I'll quickly go and pick up what we've done then, okay? Okay.
This one.
Yeah, okay.
Oh,
Yeah.
I turned it off.
Okay, no problem. Okay, I trust you. Okay, don't worry, I trust you. Okay, how? I think I already saw almost working anyways. Okay. I think Safar's is pretty much working too. Okay, if he can get his computer to work. Okay. All right. Okay, let's continue. I'll just quickly make some of the suggestions that I would make. From my UML diagram, I would probably first adjust this program a little bit because we don't really need this extra variable OX. So I'm going to start, I'm going to say I'm just going to get rid of OX and I'm going to get rid of OH. I don't really think they're that necessary. So I'm just going to maybe make it get IX. Okay, IX. IX, get IH, okay? All right. I'm going to start with LF equals insert. Wait, what's this stuff? It shouldn't be doing that. Insert. Where's the insert here? I can't even, okay. ILF equals 6, comma, the other one was IH, right? Okay, good, okay. Or IH, okay. LF, okay. So I've got its position and, okay, and IH, okay, good. So calculate the object. I'm going to calculate based on IX position. And my equation of the lens, I've now got O. I get my magnification. My new IH, my new image will be the old previous object, which I'm going to call IH. From the first case, I'm just going to put that in. So I'm going to take the previous height, multiply it by the magnification, and put it back into IH. Okay? So that's my first little setup to fix the code so I don't have to worry about having any use of the O object anymore. All right. Now I want to start looping. So according to my UML diagram, okay, let's try to get this UML diagram over here. Get my code over here. Good. All right. Okay, what I input XL, input X, okay, input this, input this. I can probably put my loop right into here now, just as suggested before by Rahim. While LF is greater than 0.001 or LF is less than minus 0.0001, we'll do my while loop. Again, because LF is a double, it's a good idea not to use the equal sign. We try to avoid that. We just try to use greater than or less than. Okay, so this is going to be in the loop. This is loop. We get the LF. We calculate O. We use the lens equation. We calculate the image height. We calculate the new image position. We print those information, and now we want to get LF again. Okay. Okay. Did I get that to the end? Right. Okay. So I got this sort of a thing. Once I've got these guys, let's see. So I've got my first lens position. This is actually probably is not going to be a great way of doing it. I'll probably have to put this again. Maybe simpler. I put another one here. Get it first, and then sorry, this one's not going to work like we did the previous one. And I'll put this get opt at the very end to get my next set. Okay, so this should now allow. So this will now allow us to run it, and it will check to make sure, and it'll keep running as long as we can. It'll keep cycling through each of the lenses. All right, so that's my if statement. Now I'm going to quickly review how each of these programs work. Okay, let's go back to our main menu. Where did I put that? To try to find out what I did with that. Did I shut it? I must have shut it. Okay. Here it is. Okay, great. Okay, sorry. Okay. Okay, so I've looked through. Let's now look at the two solutions, how these guys flow. I'll just review the flow for the gravity one. Save link. Okay. No, cancel. Okay, we already have this. Okay, save. Keep. Show in folder. And flow A. Here's my following objects guide. Let's step through it now. Okay, this was the calculation. We're going to modify and add repetition. This is the code with repetition added, at least one version of mine. Okay. In this case, my version again will probably be slightly different from your version and the version we just wrote. Each time I probably make the code differently, but this time we wrote it this way. Okay, so first of all, I need to include stdio.h because I'm using the print file and scanf, right? I'm scanning f in, I'm getting scanf to get data in, and I'm using printf. Both of those functions are in standard stdio. I have my own little function to get x and t, which I'm using, okay, to get them both, okay? And I have a function to calculate the derivative and a function to calculate the mean of the two guys. Okay, main program starts. We declare and initialize, well, we declare 1, 2, 3, 4, 5, 6 variables, and we initialize 4 of them. Y1 and T1, this is for the following guy, and Y2 and T2 I initialize as 1. Okay, and I have dy dt. So I've initialized the first guys. Okay, I then start my loop. Well, T2 is greater than 0. Okay, T2 is greater than 0. Enter the loop. Okay, get xy, y2 and T2. Okay, so I get y2 and T2. I then calculate my derivative with this function. I then calculate the mean from T1 and T2. I print the result. I then put the value that's in T2 back into T1. So the value that's in T2 I'll put into T1, and the value that's in Y2 I'll put back into Y1. Okay, and we're now ready to start our next loop. Since T2 equals 1 is greater than 0. Okay, actually T2 equals 2 greater than 0. Okay, never mind. Okay. I get another xy, so let's say I input 40 and 3. Okay, those are both stored in. I calculate my derivative, calculate the mean, print the value, move the value from y2 into y1 and t1 into t2 into t1. Check again. T2 is greater than 0. Okay. Okay, it's not equal to 1, but it's greater than 0. Get the next set. Do the same thing. Okay, now I've entered. Last time I just got. Okay, T2 equals T1. I've got a -1 now in T1. Okay, this is not wrong. Some program ends. Okay, so that would be an example of our use of repetition to be able to do this problem. Okay, and we're going to quickly run the one for the mfloat2. mflow, sorry. I'm not sure. Okay. This is moptic, so we're going to move down to repetition. Okay. So again, this is our repetition for a multiple lens system. Okay, sorry, I'm not showing the screen. Sorry. Okay, is that better now? Okay. All right. So again, our idea, so there's the idea of my picture, what I'm trying to do. I'm first calculating the first lens, I'm calculating the image, which is the object of the next lens, which then I add the next lens in, and that's going to give me the final image. Okay, so you can see here on the bottom what exactly is happening through this small animation. What I'm trying to do is my program runs, so you understand the physics. Okay, all right, so okay, in this case, I have put the subroutine functions into another file, but don't worry about that. Include math.h, okay, because I want to use absolute value function. So C is a function for absolute value. I want to use that guy. I get it from math.h. This is good style. Don't use numbers in your program. Like in Carlos, in your version, I used less than 1, right? 0.001, right? You should not do that. That's bad style. Okay? So what you should do is put a define here, EPS. So for example, small number. And I'm going to make my small number 1e to the minus 23. Okay? So then I start, so this is a preprocessor directive. So anywhere it sees EPS right here, it's going to put in the value 1e to the minus 23. Okay, so before the compiler runs, the preprocessor will first replace anywhere I've got EPS written in my file, will replace it with the number 1e to the minus 23. Okay, before the program even starts. So it won't take anything okay. All right, so I define that. It's going to preprocessor replace anywhere you see EPS with 10 to the minus 23. Okay. Main starts. I declare all my value variables, 0 and I, IX, IH, LX, and LF. Okay? So I'm just going to use 6 variables here. I first get my original image position and its original image height, 0 and 1. I then get my first lens's information, position 10 and 5 focal length. I then check, is the absolute value of the focal length greater than EPS? If it is, then I'm going to keep running my loop. And yes, okay, enter loop. It's checked. The key is okay, this is greater, it's greater than epsilon, enter loop. Okay, calculate O. Use the lens equation to get I. Convert I back into the coordinate system that we have. Find the image height. Get our next lens information. Okay, right here. Next lens, 3510. Check. Is the value of LF greater than EPS? It is. Okay, enter the loop. Calculate the next O. Calculate the I from the lens equation. Put it into the correct coordinate systems. Calculate the height. And get the next lens. Okay, this time I put 0, 0. That means we want to end the program, right? Because FF is 0 is not greater than EPS. Okay, it's not greater than 1 to the minus 23. Okay, so I'm going to end the thing, and I'll probably print my final position of my final image after my lens system. So I'm only going to print it. So in this case, I only want to print where the final lens is. I'm not printing the whole sequence of positions. Okay, so that will give me my final position here. All right, and then return 0. Okay. Final question we want to work on. And this will complete our work on flow, I think, totally. Will be to take the nth root of P. Okay, okay, we're going to autoly converge to a root. We're going to start with this guy, as they're going to be our starting function file. Getting the x squared one, okay? We're going to start with this guy, start with this program. What's that doing? Okay, so you're going to get this program, and then put repetition to allow us to converge. Let's remember how our m root 1, when we talked about how that was going to work, that guy, right? Let's quickly look at this guy first, so you remember how this will work. And then we'll show the UML again, so you understand the physics again. Just review it. For root finding numerical analysis. So this is the third type of problem we can sometimes face. Okay, we calculated the square root of 2. We do it by doing y equals x minus 2. Let's try to get it approach to 0. And we basically ended up, this is sort of what we're doing. This is a graph showing what we're trying to do, right? We're getting a number that's too small. And that's going to have a number less than 0. A value of x is too big. That will give us a value greater than 0. So we know somewhere in between it crosses the axes. And we're just trying to find the crossing point for our equation. Okay, that's the algorithm we're using. Now, the previous one, we just typed in x1 and x2, and we got x. And then we tried, okay, we manually said, oh, this is too small. Okay, let's split it between. We'll try something between. This time we want to make it all automated. So that will be our UML diagram is here. Keep. Okay. Open. Oh, good. It does. Okay. Okay. So this was our program we want to calculate. This is our basic UML to do one calculation. Okay, we input this. input the input, oops. Do a single if, okay, stop when our answer is going to be close enough. Okay, so now we have to have the loop in here to start do the iteration in here. Okay, first of all, we want to find a value of x that is halfway between to make our guess. We solve the equation for y, and we check the answer. If it's less than 0, we substitute x for xs, or strategy we set to xs, and then continue the loop. Okay, so this will be the first program we want to do. Okay, we've done this program in which we fixed n and p. N was squared, and this was 2, square root of 2, right? But we're going to now try to use the whole program now to do the complete loop. Okay, so please download the function that we're going to start with. It's going to be is this guy M3 pointer. Okay, that's the guy we're going to be working with now. So please download this little guy right here. Okay, and then we'll work on that. So you've got two things you're gonna have to do here. One is going to be the if statement and the repetition statement. So there's a couple of things that are going to be here. So right within the while loop, there's also going to be an if statement. So it's not as straightforward as the other ones. So again, this is going to be basically in the main program. We're going to be just in the main program. Okay, where's my UML to let you see what we're working with? Good. Okay, there's our UML no, that's the wrong UML. Okay, the UML for this one is this guy. Okay. All right. Pardon?
Are we already make a one for that, right?
Did we already make a while?
Yeah.
Oh, we did that. We did that program already.
Yeah, that is the customer statement for me. It is last week or last week.
Okay, we did that one last week then. Okay, fair enough. Okay.
No, you came here to. I got a file. Can you?
Okay. Right. Okay. Make sure. Okay, we've already done this one. Then we can skip over it. That's good. Okay.
This one. This VXL.
Yes.
The line right here.
Oh yeah. Okay. Right. Okay. Yes. Right. Okay, that's what we did. Okay, we did that before.
Newton root, yeah.
I wrote it. Okay, I did for Newton. I called it Newton. Right. Okay, yeah, I did that last week. Okay. 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 Sorry about that. This is the one I did last week. Okay. Right. I did that as an example last week. Right. Okay. So I was going out of order last week. Okay. Forget about this guy. Okay. Sorry. We already did it. Okay. Last week. Okay. All right. Okay. Then we don't need to. Then we'll. Okay. Good. All right. Okay, thank you, okay. All right, then we'll move on. Sorry about that. I forgot that we've done that guy. Okay, let's get back. Okay, better get back. Chrome, where are you? Let's go. Sorry, I'll get that new. Okay, so in this case then, we can quickly look at the, we have the code here. Yeah. All right, okay, good. Okay, so let's walk through the code then. Since we already did it, okay, show and open. Okay, so there's our basically our repetition code is this guy. You can see here we basically now set a few gain to avoid using. Let's walk through it. Okay, preprocessor. Pardon? You don't have what? Oh. Oh, okay. Probably because I was just doing that by hand, right? I didn't remember to do that. Yeah. Okay. This is the way I did it before, right? Each time I program, it's not going to be exactly the same, right? Right, Carlos? Carlos. Every time I write a program, it's not going to be the same. Every time I write it, it's going to be slightly different. I can't write the exact same program each time. Okay, so this is a better way of doing it though. Okay, standard input and output. I'm using math.h to calculate the absolute value. Okay, because I want to use an absolute value function, so I'd rather than doing my own function to check that less than or less than, I want to use an absolute value one. If possible, use all people functions other people write. I declare this to help the programmer. Everywhere EPS appears, it is replaced by 0.01. This allows me to easily change the number. If I find that 0.001 is too big, I can just change it right here at one spot, and it will change all the way through the program. Okay? If I think, oh, I should be EPS equals 0.0001, and I define PP as 2, again, I can easily change the number. So let's say I decide I want to do the square root of 3. I could change, just put 3 here, and I'll do my whole thing will run the square root of 3. Okay, rather than having to go into the code. Okay? All right. This is again the prototype. Another prototype. Function main starts. Okay, I put 1 into x1, y1. Since I'm doing the square root of 2, x2 is going to be pp. Okay? The big number, right? The big number, pp. Okay, probably not a good name of, not a great name. And I don't bother initializing, and didn't bother initializing y1 or y2. I also declare 2 new guys, x3 and y3. Okay, so x1 is going to be less than, x2 is going to be a bigger than 1, right? Okay, so that's where the x, okay. So y1 equals, equation from x1, we find out the value. y2, the equation from x with x2, calculate the value. I then check, is f absolute value of these two things greater than the required value? If it is, okay, greater than 0.01 is how close I want the root to be. Okay, if I wanted it closer, I could make EPS even smaller or smaller. Okay, now since they are equal, we enter the while, we enter the while loop. We calculate the middle value, we calculate the new y3, and we find, oh, okay, it's positive. If y3, y1 times y3 is greater than 0, we are equal to 0, y1 should be less than it. If this is going to be greater than 0, x1 equals x3, y1 equals y3, else x2 equals x3, y2 equals y3. Okay, so I'm just seeing whether it's less than or equal to 0. I could do it a different way too, but this way I'm just trying to, I'm sort of eliminating a possible mistake that one could make in programming. Okay, this is not true, so I set it to 0. So this is going to be this guy. Now I've moved narrow in again. Okay, calculate again, absolute value, calculate again. So split. Okay, keep grouping, go again. Continue skipping steps. Finally, I can then print out the value, final value of the root. Okay, so this is basically our key function. There's two things, the equation and the calculation. All right, that provides our calculation of roots. Okay, now, okay. Absolute value function. AP, absolute value of a number. Do you know what absolute value means? Yeah, the absolute value, yeah, right. That's the function just to do the absolute value. Okay? Someone else wrote it, so I'm not going to rewrite it myself. Right? That it's much clearer to use that. It's written, it's a standard function. Okay. All right. Any other questions? Any questions for anybody online?
No, professor.
I have
Okay,
a
thanks.
question, Professor.
Yes, Rahim?
In the lens question, you have put the condition as LF greater than 0.001 less than or less
We're talking
than
about, yeah,
the lens one.
right? Okay, we're my
Can't we
lens
put,
equation. Oh, my,
yes, can't we put the condition as LF not equal to 0?
No. Because if it's a okay, let's say let's go back to where's my lens program? My lens program. File, open. Do I have the lens program somewhere here? Pointer, ammo. Okay. All right. Okay. Is this no? This I don't. Okay. Sorry. I'll try to. Sorry. I gotta find that code. Sorry. Just find that code. Ammo.
MO6IF. Yes, this one.
This one, right? Okay. That's now after I done the loop. I gotta get the one with the what have I done? Sorry. Just a sec. Sorry. I think I got too many windows open. I'm sort of confusing myself. Just a sec. I'm gonna close some windows so I get okay. This guy okay, that's multiple lenses. Oh, this is the one you say equal to 0, right? No, because anything that's a floating point may never be 0.
Yes, so if we are
That
saying
may
it
never
is
be.
not equal to 0, it will be anything other than just 0. Wouldn't that be the
Yes, but a
case?
computer, but computers cannot store 0. The
Okay.
computer cannot store 0 in a double. Okay? A computer
Okay.
cannot store 0 in a double location. It can store. Okay, let's try to. I'm gonna throw a notepad up. It's like okay, just like I better. That's probably easiest. Like where's this guy gone? I'll try to explain what we're talking about. Where's my notepad? Where are you? Okay, here we are. Let's get a new file. New. Okay. All right. Integer j equals 0. Okay. This stores 0 in the. What does this do? This thing stores 0. Okay.
Okay.
Double j equals 0.0 not stores 0. Okay?
Okay.
Because for a double, 0 is not, you cannot store 0. It will store a very small number. So it's going to store a very small number, but not 0. So it may store 1 e to the minus 26. Okay? Or,
so that means we cannot do this kind of a condition with a variable, with a variable of double type.
With a variable double type, you cannot use if A equals B. If J, okay, let's call this A. If A equals 0, no, you can't write that. No. You can write if J equals 0. That's okay because J is an integer. If A is a double, you cannot write if A equals 0.
Okay.
Okay?
Yes.
Because it probably will never be 0.
Okay.
Okay, good. Okay. All right. I'm going to, okay, now where was I? I'm sort of lost, right? Okay. Okay. Oh, good. Oh, yeah, now I remember where we are. So today's class, we're going to start now. Finish the review. 我们的复习结束了，我们现在 so hello. How are you? Okay. Review is finished. We're starting the class now.
It's 10 more.
With time to class, but today's class is supposed to start right now at this part. Okay, anyway, so it's okay. Okay, all right. All right, we'll get started. Okay. All right, now we're moving into, okay, basically what I've finished now is C programming is now finished. Okay, we finished studying C programming, so you can now write C programs to do basically anything you want. Okay, now, so now we are moving into more advanced programming techniques that can help you do programming more better. But up until now, we've now basically finished teaching C programming. You now know how to write a C program, all the key things that you need to know. All right, you can compile, run, use variables, and pointers, and functions. That's all basically C programming is, okay? And you know how to use file input and file output, okay? So that's basically everything. So now so the next thing we want to talk about is more how to make your programs more, different ways of strengthening your programs. Arrays and records can be done for this, okay? It's not necessary to use them, but we can to make them, okay. So how can we look at the difference between arrays and records? I want to stimulate the discussion with a university discussion of 3 different ways of approaching a question. Using an arrays approach, a records approach, and a variable approach. Okay, the question was how to get a girlfriend. You don't have? You can't see my screen? You can see my screen?
I can see the screen.
You need this advice.
Yeah.
Okay, how to pick up a girlfriend. Okay, this was a discussion that we had at university. Pardon? We had 4 of us discussing. All right. And I think each person's discussion had sort of a different idea. Okay, 3 guys, actually 4 of us. There was me, who said, you don't need a girlfriend. Just study. There was a Canadian guy by the name of Paul Beckwith. Now, he said he made his argument. He says, okay, you select one girl, and then you try to be nice to her, you try to get to know her, you find out what she likes, what she doesn't like, and focus on one girl, and you focus on one girl. Okay, that's basically a variable approach. Okay, all right. The next guy was the name of Roger Ho. Now his approach was very different. He's from Hong Kong. He's from Hong Kong, like Carlos. Yeah, he was from Hong Kong.
But my last name is Lau, not Ho.
Okay. Anyways, Roger was a good friend of mine, and he basically said, you don't go looking for a girlfriend. That's stupid. You make sure the girls are looking for you. And he says, okay, what you want to do is you want to first of all make sure they think you're rich. Okay, so he said you need a gold chain, a silk shirt. Then the girls will start to come to you. Okay, and then there was another guy, this Dahilan, this guy from I think India or Pakistan. I can't remember which of the 2. Dahilan is Indian?
Yeah.
Okay. Anyways, he looked a little bit like Ab or Ali. I don't remember that.
Okay.
Then he said, he took an array approach. He said, don't be stupid. You know why you want a girlfriend. You just do the exact same thing to all the same girls. You just come up to a girl and say, hey, you're beautiful. Come back to me, let's have sex tonight. And
Okay.
So this, we were sort of thought, what kind of, that's not going to be successful. So anyways, 1 year later, we got together and had discussion again, and to see how the different people's approaches worked. Okay, me, I got good marks in school. I had no girlfriend, so I did quite well in school. Roger, okay, Paul, he had one girlfriend, and she was one of the top smartest girls, and a very beautiful and smart girl. She wanted to become a medical doctor. Okay, so he focused and ended up becoming close friends with that one girl. Roger, well, he had 4 different girlfriends. He had one girlfriend. He was in second year. We were in second year computer. He was in second year computer science. He had one girlfriend who was the top of the class in third year computer science. This girlfriend had a purpose to help him do well in school. Nothing else. That girlfriend, they just studied in the library together. Girl number 2, she was quite beautiful and fun, so she was for sex. Girl number 3, her father was a rich Hong Kong tycoon, so that's where he got the money, so that he could impress the other girls from. And there was a 4th girl, who's just sweet, nice sweet girl. And I said, what's she? She said, oh, she's the girl I'm going to marry, because she's a nice, conservative, sweet girl, and I think she'll be very good with my children. And I was thinking, wow, that was Roger. So he had these 4 girlfriends. None of them know each other, obviously. Oh, pardon?
Okay. Sorry.
So,
It's difficult to.
Pardon?
It's difficult to handle 4 girlfriends.
One girlfriend lived in Toronto, which is about 60 kilometers away from where we are. So and for one other girl, the girl he studied with in the library was okay, because she always was studying in the library. So he would take a day off occasionally to see girlfriend for fun girlfriend. And fun girlfriend, he just told her, well, you know, I have to study hard at school because I'm not that a good student, so I have to be in the library most of the time. So that's how he got around all this thing. Okay, now the Highland is the most interesting, the ray-based approach. I said, well, how did it go? He said, well, I calculated this past year, I went up to at least 125 different girls. Wow. And I said, okay, what was the results? About 15 slapped me on the face and told me I was a dirty scumbag. But 2 girls came back with me. So he said, I've had a pretty good success. And I said, what were? Where did you find the 2 girls? Oh, they were drunk. They didn't know what they were doing. So, good grief. So anyway, so the Highland was taking an array-based approach, doing the exact same thing to all these girls, and while Roger was sort of more of a record-based approach, each person for one specific purpose, and well, Paul was basically this variable-based approach. So Paul, a basic approach, one target, not too pretty, get to know her, do your research, become friends, habits, dislikes, happen to pass by her house, happen to take same class, ask her out on a date, 3 months later, successful. Roger, your image, the shirt, make girls want you, and then make yourself available. Very nice strategy. Choose 5 or 6 girls who don't know each other, and that's basically how we tried to work at it, to meet specific needs and have specific functions. Okay, and then finally he said, oh, his last step after he got all the girls working in love with him was to start to let them occasionally meet, so they feel competition. He said competition is very good, because girls will think you are valuable if there's other competition. If they think she's the only girl who wants you. And to Highland, yes, get a list of all the girls at the university. To each girl, go and say the same thing. You are so beautiful. You may not have noticed me, but I have noticed you. All these nice words. I dream of you every night. You know, Canadian nights are so cold. If we were together, we could keep each other warm.
Yeah.
Oh, how nice. Okay, anyway, so the 3 approaches. All right, we are going to study arrays now, okay? anyways, okay, and that's basically what next up, okay, will be arrays and records. Okay, let's move on to arrays. I don't have much time. I just want to give a quick introduction though, so we know what we're going into for next week. And if I can find my spot, where's my correct guy? Here we are. We're going to go to the arrays. Arrays. Open. Is that the one I want? Where'd it go? Okay. I got too many windows open. Sorry. I'm gonna have to shut some of them. Sorry, I just shut down some windows. I apologize. Okay, okay, in just a sec. Okay, sorry. Where are we? Yeah, where did it go? Shoot. Here we are. Have I got too many slides up? Okay, here. I think I still got too many things open. I can't find where the one I want. There's arrays, okay. I got too many open. Okay. I got that already. Close it. Exit. Come on. Okay. Okay. All right. So when we start talking about arrays and records, variables and pointers, it's crucial that these are the ways we structure our data. So how we structure our data are very important. So this is one perspective on this. Show me your flowcharts and conceal your tables, and I shall continue to be mystified. Show me your tables, and I won't usually need your flowcharts. They'll be obvious. So if I organize my data, if you know how you're organizing data, it will tell you how you need to process the data. So, okay, another perspective from Kerningham and Bob Pike. These are the guys who invented the C language. Once the data structures are laid out, the algorithms tend to fall into place, and the coding is easy. Okay, so first you need to get your data, decide how you want to structure your data. Then you need to decide your algorithms. That's the UML. Then the coding, the C coding is what you do at the very end. You don't try to start coding first with C. No, you have to first get your UML and your data structures, how you want to organize your data first. Okay. All right. So that's the crucial thing, issue that we need to work on that. Okay. So, and okay, let's move on. Okay. So let's go, and we're so and. Come on, where are you? So arrays are the first thing we want to do. So ANSI C has many data structures are built in. So arrays and records are built in. All the other data structures that are common, you have to create yourself. Okay? Generally, there are 8 ways of structuring data. And only 2 of these are built into C. The other 6 ways you have to do it yourself. You set up your own structure. You have to make your own data structure. And C allows you to do that. So C has the ability to let you make the other data structures yourself, to make your data structures the way you need them to be so that they can be the most efficient. So an array is basically a grouping of data of the same type. So this is this type of data structure, okay? Example, you have a whole set of variables together that are all fixed point, or that are all floating points, or a set of pointers that are together. They have to be the exact same type. Now, we're going to talk why use arrays. We'll move to that next week. Okay, finished. Okay, see you guys all next week. Thank you. And I'll check to see what did we say about this course? How are we grading this course? I forgot. I think it's let me in. Okay. Okay. All right, right. Okay, yeah. No midterm. Right, yeah. 70% in class, 30% project. Okay. All right, yeah, okay. Fair enough. Okay, good. Okay. All right, that brings it close to today's class. See you guys. Thank you. 谢谢你们.
Thank you,
Thank you,
Professor.
Ansari. Thank you, Rahim. Ren,
Uh,
Renee, are you still there? How's your hospital trip? Are you still in hospital, Renee? Renee? No, Renee. Okay. All right. Bye-bye. Good night.
Good
Professor,
night.
Yeah.
so there will be no midterm.
No midterm, no.
Okay. And Professor, I won't be, I might not attend the next class because I have my flight on that day.
Oh, okay. Okay. You're going to finally be flying to Taiwan. Yay!
Yes.
Okay, great. Okay, good. All right. Good. All right. Fair enough. Okay, good. All right. Then okay. Well, we're looking forward to welcoming you to Taiwan, Rahim.
Thank you, Professor.
Okay. And I hope we'll be able to welcome Ansari very soon too, and Renee. Okay. Bye-bye.
Bye.
Good night, Professor.
Yeah.
Nothing. Good night, Professor.
Good night.